So I'm going to take you on a little bit of an adventure today. And that adventure starts in the 90s. Because as much as it feels like 5 minutes ago, it's apparently 30 years ago? And that feels wrong. In the 90s, we deployed software to physical servers. You know, big hunks of metal that we put in racks. And everyone who wanted to deploy software deployed to physical servers. And it had a bunch of problems because like we couldn't really isolate processors. Like we didn't have any of the modern wonders of, you know, C groups and CH roots. Like we barely even had Linux. I remember Solaris. It was not a good time. And it was super inefficient because we mostly treated servers as like one app goes to one server. And you'd end up with some servers that were pegged doing, you know, a bunch of stuff, and others that were doing nothing, just wasting power, space, and heat. And growth meant going through procurement processes. Like, who really likes filling out forms and mailing them to someone to buy a server that'll arrive in 3 months? Just because you wanted to auto-scale. But how did we actually deploy software? Well, you know, with the rise of dynamic languages at the time too, there was a lot of FTP. You'd have a group of sysadmins who would get handed software after it had gone through QA, and then they'd be uploading software to servers, reloading things, and well, that led to a lot of this. Because, you know, your local machine was nothing like production, and you didn't really know if your software was going to work, and you hoped QA would catch everything, and it didn't. But then, in the late 90s and early 2000s, we got a great piece of technology that changed the world: virtualization. And this gave us progress in a bunch of different waves. The first separated the software from the hardware. You no longer were targeting the like exact specific machines you were going to deploy to. You targeted the virtualization platform, and that gave us a bunch of resource isolation. For the first time, you could deploy multiple apps to the same server and like have some vague idea that they weren't going to be fighting each other too much. And you could like scale your resources beyond those of a single machine as things like SANs became more available. And heck, these days, you know, you can have a box of GPUs that you connect to a server, and that still blows my mind. And it revolutionized development too. Because for the first time, you could basically have production on your workstation. And you could even build an image that could be copied across different environments. You could deploy to like staging and then production, and it would be the same golden image that you'd baked earlier. And that kind of gave us a lot. And in the late 2000s, that led to another wave: the cloud. There were a bunch of startups spinning up because we were slowly recovering from the dot-com boom. And basically everyone had a bunch of data and no idea what to do with it because hard drives were really expensive and took a lot of space. And so this little book company introduced the simple storage service, or as we now call it, S3. And it was infinitely-ish scalable storage for everybody, where you paid for what you used as you needed it. And basically everyone was like this. And then they went and did, apparently my slides broke, but that's fine. Then they did the same for compute. And it revolutionized the way we think about infrastructure. How many people today try deploying software by ordering a bunch of physical servers? Or even renting them from someone else? Basically nobody, right? We go to a cloud. And then other people came to revolutionize the developer workflow on top. Heroku, Cloud Foundry, and then Google's App Engine all tried to build a platform so you could focus on writing software, and they would manage the infrastructure for you. And, with Heroku create, git push, you are deployed. And all of these parsers were built on a relatively new technology called LXC, or Linux containers, originally developed by IBM, but then used by all of the early parsers, CI platforms, to give you lightweight isolation and improved density of compute. But then LXC had a packaging and ecosystem problem. Using LXC as a developer sucked. You didn't have registries. You didn't have any of the tooling that we have today. And the parsers of the day had a really bad lock-in problem because they all built a bunch of proprietary technology on top of LXC to abstract away all of the problems from you. And you couldn't really interact with them, and you couldn't deploy your Heroku build pack anywhere else. And that really sucked. But it was about to change. With containers. In 2013, Docker was released. And Docker gave us an ecosystem around containers that we all still use to this day. And it also gave rise to another interesting piece of technology that everyone here should be familiar with. In 2014, which is weird to believe, it's less than 10 years still, Kubernetes was released. And whereas Docker gave us an ecosystem around containers, Kubernetes gave us an ecosystem around platform building using originally just Docker. And that was really exciting. And well, Kubernetes adoption kind of just went like this. But it often didn't reduce cost of compute in the same way that virtualization had done before, and the way that some people using LXC had managed to do too. And we brought back a lot of the operational toil that came before. And at the same time, some other people were working on functions. Functions once again reduce the responsibility of the developer and promise to reduce a lot of operational toil. But every functions as a service platform has the same problem as early parsers. They're ripe with lock-in. Have you ever tried to deploy a Lambda function to not Amazon? Or run it on your laptop in development? It sucks. What can we do? Well, what if we had an answer? That answer, I'm hoping, is WebAssembly and rethinking how we build microservices. So now it's time for a little demo. And like all living on the bleeding edge, I spent most of today dealing with problems from the 80s, which is to say DNS. And I fixed it about half an hour ago, so let's hope it still works. So we have here the source code for a little to-do app. Using Spin, which is a WebAssembly runtime and platform, we have a very simple API. Get some to-dos, create a to-do, update a to-do, delete a to-do. That's all it does. It uses SQLite as its backend. And then, we can get some to-dos, we make a query, and then return it back through the API. Like standard SQL, nothing too fancy. This doesn't even use a wrapper shim around it because of how little it does. So we can run that locally. And we have a static file server for the front end, and then the API being served separately. And if we go here, hey. So give a talk at Civo Navigate. I can't quite mark that as done yet. But I can remind all of you that you're awesome and wish you a very good day. But now, Like, it's all well and good running something that simply on your laptop, you know? But what about the real world? Well, if you want to do it the easy way, deploy, deploy, deploy. Live demos that rely on deploying things are a scary time, but the worst case is I do have one I prepared earlier. But no, here we go. I don't want the API. Is DNS being a problem again? I deployed a new database. I need to run migrations. Look at that. Spin, cloud, SQL. Need to figure out what database I'm using. Love when things have random names. Thick. Oh. Is that what it is? Yes. Ugh. Go away. No one password. I don't want to give you anything right now. Hello. How is everyone today? But, you know, this doesn't really show you the power of not being locked into a single cloud vendor. So what if you could deploy the same thing to Kubernetes? That would be great, right? Well, it turns out you can. So this one I did deploy earlier because live demos involving like updating containerd, I've had a bad track record with. But we have a very simple deployment. We pull our application from a standard container registry. We, have a standard command, and then we load in this little config file. This config file is this token expires tomorrow, so if you want to steal it and play around with a database, you can. I don't really mind. It just tells us that the default SQLite database should be backed by libsql. It's hosted here, and here is the authentication token. And if we kubectl get pods, you can see we have 3 pods. And if we go to, this was the one I was showing earlier, actually. There we go. So that is that running in Kubernetes, talking to a real database, hosted externally, with the same software that is actually running on the Fermion cloud right here. And thank you. Does anybody have any questions? Cool. Then, oh.
Yeah, can you talk about,
Can you mention a few words about the runtime cluster you're using?
Yeah, so that leads me to an excellent point. The way I was deploying WebAssembly to Kubernetes was via the Wasm operator. The Wasm operator handles setting up the runtime class stuff for you, and there's going to be an excellent talk on that by Sven tomorrow. And I think you should go to that talk. Cool. Well, if anyone wants to chat to me later, I'll be around the Fermion booth tonight and tomorrow. Or find me around. I'm easy to recognize. There's not that many people this tall. Have a great conference.